These are your notes for Unit 10, Day 1 of Algebra 1. If you would like to see your warm-up, review question, or any test questions we covered in class today, just look at your finished notes. So today we are going to talk about how to solve equations that contain quadratics, or equations that have a degree of 2. Today our method of solving those are going to be the method called taking square roots. So we're going to use the square root property to solve quadratic equations. So how did we solve these in the past? So if we had x squared minus 64 equals 0, to solve this, using our previous method, we would factor it. And remember, x squared minus 64 is a difference of two squares. So you could factor it into x plus 8 and x minus 8, and then equals 0. Now using the zero product property, since x plus 8 times x minus 8 is equal to 0, the only way to multiply two terms together to get 0 is if one of those is 0. So either x plus 8 is equal to 0, or x minus 8 is equal to 0. So subtract the 8, and one of my solutions would be x equals negative 8, or add the 8 and add the 8, and your other solution is x could be positive 8. Remember, you can always check by plugging them back in. If I took negative 8 and squared it, I would get 64, and 64 minus 0 is 64. If you took 8, plugged it in, and squared it, you would also get 0. All right, what if we had 2x squared minus 98 is equal to 0? Well, pull out their common factor first, which is the 2. So you would have 2, and then times the quantity x squared minus 49 is equal to 0. And then x squared minus 49 is a difference of two squared, so it would factor into x plus 7 and x minus 7. And now we get to use the zero product property again. So either 2 is equal to 0, x plus 7 is equal to 0, or x minus 7 is equal to 0. 2 doesn't equal 0, so that's not a solution. Subtract the 7, and one of your solutions is x is equal to negative 7, or add the 7 and add the 7, and your other solution would be x equals positive 7. And that's how we solved these types of quadratic equations in our previous units. So now we're going to use a new method, and it's called the square root property. So for instance, if you had x squared is equal to 49, well, to get rid of something squared, if it's by itself, you can take the square root of both sides. And so if x squared is equal to 49, we could take the square root of both sides. And remember, when you take the square root of x squared, you get x. Well, when you take the square root of 49, notice you invented that square root yourself. So it could be positive or it could be negative of that square root. So x could be positive 7 or x could be negative 7. So again, when you invent the square root sign yourself, so when you take the square root of both sides, you're inventing that square root. You need the positive or negative root. So if x squared is equal to a, then x is either going to equal the positive square root of a or the negative square root of a. So if you have something squared in an equation, and it's the only term, so there's no other variable term, it's just one expression squared, your steps are you get the squared term or the squared term alone. So you want to get whatever term is squared, you want to get it alone. And then you take the square root of both sides. So you're going to square root both sides. So on number 1, we had x squared minus 64 equals 0. Well, on the previous slide, we factored and solved. You can still do that. Or now, get that squared term by itself. So get x squared by itself, and you would get x squared equals 64. Well, now using that property that we just used, you can take the square root of both sides. And since you invented that square root, put plus or minus. So x is going to equal plus or minus 8, and that is what we got up above. Or on number 2, 2x squared minus 98 equals 0. Get that x squared by itself, so add the 98 over, and you would have 2x squared equals 98. Then divide both sides by 2, and you get x squared equals 98 divided by 2 is 49. Then take the square root of both sides, and again, put the plus or minus when you invent that square root. So x is going to be plus or minus the square root of 7. And notice those are the exact same solutions that we got up above when we factored and solved. All right, so let's look at the next two. 3x squared is equal to 19. Well, we need to get the x squared by itself, so let's divide both sides by 3. And we have x squared equals 19 over 3. To solve for x, take the square root of both sides, and we'd get x equals plus or minus the square root of 19 over 3. Well, remember, we need to rationalize that. So we can make that plus or minus the square root of 19 over the square root of 3. And then, to rationalize, get rid of the square root in the denominator, and 19 times 3 is going to be 57. So this is going to be plus or minus the square root of 57 over 3. On number 2, 5x squared equals 13. Why don't you pause the video and try to do number 2 like we did number 1. All right, so divide both sides by 5, and you get x squared equals 13 over 5. And then take the square root of both sides. You invented that square root, so plus or minus. So x is going to be plus or minus the square root of 13 over 5, which would be plus or minus the square root of 13 over the square root of 5. Then rationalize, multiply the top and the bottom by the square root of 5. And 13 times 5 would be 65. So we're going to get x equals plus or minus the square root of 65 over 5. All right, let's look at some more examples. Now notice, number 1, we have x minus 5 in parentheses squared equals 36. So notice, we still have an expression squared. So if I want to get rid of that squared, notice that term is alone by itself. I could take the square root of both sides. When I take a square root of something squared, it'll go away. And so I'm just going to be left with x minus 5 on that side. And it's going to equal plus or minus the square root of 36 would be plus or minus 6. Now you're going to set up two equations. X minus 5 is either going to equal negative 6, or x minus 5 is going to equal positive 6. So now we actually have to solve. So we're going to add 5 to both sides. And we get x is equal to negative 1, or add the 5 to both sides. And x is going to equal positive 11. So my two solutions that could work would be x equals negative 1 or x equals positive 11. Number 2, remember we want to get the squared term alone. So the first step we're going to have to do is divide by the 5 and divide by the 5. And then we have x minus 1 squared equals 4. Then to get rid of that term that's squared, square root both sides. And so we get x minus 1 is going to equal plus or minus the square root of 4 is 2. So then set up your two equations. Either x minus 1 equals negative 2, or x minus 1 is going to equal positive 2. Then solve both of those. So add the 1 to both sides. X is equal to negative 1, or add the 1 to both sides, and x would equal positive 3. So my two solutions could be x equals negative 1 or x equals positive 3. All right. Why don't you guys pause the video and try these two? All right, so we're going to take the square root of both sides, and then plus or minus. And so we would get x plus 2 equals plus or minus the square root of 12. The square root of 12, we could break that up into 4 times 3. So this would be plus or minus 2 root 3. And then write your two equations. So either x plus 2 equals negative 2 root 3, or x plus 2 equals positive 2 root 3. And then subtract 2 from both sides. And now these are not going to be like terms, so that negative 2 is just going to be out in front. So it'll be negative 2 minus 2 root 3, or x equals negative 2 plus 2 root 3. So those would be your two solutions. Okay, on number 2, first step, get the squared term by itself, so divide both sides by 5. And we would have x minus 3 squared equals 5. Then take the square root of both sides, put the plus or minus on the second square root. So we would have x minus 3 equals plus or minus the square root of 5. So either x minus 3 equals negative square root 5, or x minus 3 equals positive square root 5. And then add the 3 to both sides. And so my two solutions would be x equals 3 minus the square root of 5, or x equals 3 plus the square root of 5. And so those would be my two solutions on number 2. All right. Number 2, we have our squared term by itself. So take the square root of both sides. And so we get 2x plus 3 equals plus or minus the square root of negative 4. Well, remember, you can't take the square root of a negative number. So this is going to give me solutions that are not real. So we're not going to have any real solutions. So this is going to have no real solutions. All right, on the next one, take the square root of both sides. And then we would have 2x minus 1 equals plus or minus the square root of 18. 18 is 9 times 2, so this could be 2x minus 1 equals plus or minus the square root, plus or minus 3 times the square root of 2. And then we have 2 steps to solve, so first add the 1. So I would have 2x equals 1 plus or minus 3 times the square root of 2. And then divide both sides by 2. And we would have x equals 1 plus or minus 3 times the square root of 2 over 2. Or we could write this as 2 separate solutions, 1 plus 3 square root 2 over 2, and x equals 1 minus 3 square root 2 over 2. All right, let's look at the next two. 3x minus 5 squared equals 17. So take the square root of both sides, and we can put a plus or minus in front of the 17. So we have 3x minus 5 equals plus or minus the square root of 17. Now you can separate it into 2 separate equations like we were doing initially, or now we can just solve it all together. So I could add the 5, and I would get 3x equals 5 plus or minus the square root of 17. And then I would divide both sides by 3, and I would get x equals 5 plus or minus the square root of 17 over 3. And then you can write it out separately or leave it like that. So it would be 5 plus the square root of 17 over 3, and x equals 5 minus the square root of 17 over 3. On number 2, first step, get the squared term by itself. So divide both sides by 3, and you have 4x plus 5 squared equals 8. Then you can take the square root of both sides, and so you get 4x plus 5 equals plus or minus the square root of 8. And 8 is 4 times 2, so this can be 4x plus 5 equals plus or minus 2 root 2. And then to solve, we can subtract 5 from both sides. We get 4x equals negative 5 plus or minus 2 root 2. And then divide everybody by 4. And you get x equals negative 5 plus or minus 2 root 2 over 4. And I'm going to leave that answer as that condensed version. All right, let's look at a real-world example. So on the moon, the distance, d, in feet that an object falls in time, t, in seconds, is modeled by the function d of t equals 8 over 3 t squared. Suppose an astronaut on the moon drops a tool. How long does it take for the tool to fall 4 feet? Well, the distance, d of t, is equal to 8/3 times the time squared. Well, they're telling me that the distance is 4 feet, so we're going to take 4 feet and plug it in for the distance. So 4 is going to equal 8 over 3 t squared. Now we're going to solve for t squared. So get rid of the 8/3. We'll divide both sides by 8/3. 4 divided by 8/3, well, when you divide by a fraction, multiply by the reciprocal, and we would have 12/8. And if I reduce that, I get 3/2. So 3/2 is equal to t squared. And then we would take the square root of both sides, and then plus or minus. So t is going to equal plus or minus the square root of 3/2. And then we can break that up, square root 3 over square root 2, and then rationalize the denominator. So times square root 2 times square root 2. So my time is going to equal plus or minus the square root of 6 over 2. But since we're talking about time, time is only going to exist on the positive side of the axis. So the time is going to be the square root of 6 over 2. And then if we were actually to figure that out, we could take the square root of 6 divided by 2. And we would get the time when it would take approximately 1.22 seconds for that tool that the astronaut dropped to reach the ground. All right, let's look at a geometry example. So determine the lengths of the sides of the rectangle using the given area. Give the exact answer and the approximate answer. So the approximate answer, we're going to use our calculator. So find the area. So the area of the rectangle is 45, and we have side lengths x and 3x. Well, remember, area of a rectangle is base times height, or length times width. So my area is going to equal 3x times x, and 3x times x is 3x squared. Well, they told me that the area was 45. So 45 is going to equal 3x squared. Get the squared term by itself, so divide by 3, divide by 3. And 45 divided by 3 is going to be 15. So 15 equals x squared. Then take the square root of both sides. So x is going to equal plus or minus the square root of 15. Well, since it's the side length of a triangle, I just want the positive root. So that side's going to be square root 15, because that's our x. And then this side would be 3 times the square root of 15. So those are going to be the length and width of your rectangle, and these are in centimeters. So those are the exact answers. Your approximate answers, now we're going to use our calculator. So if we went in and we found the square root of 15, so this side would be 3.87 centimeters. And then 3 times the square root of 15, this side would be 11.62 centimeters. So this is your exact answer, and this is your approximate answer. All right, your homework is from 10.1. Let me know if you have any questions.